Hi guys, welcome back to Data Every Day. Today we're looking at a data set of Uber and Lyft cab rides, and we're going to try to predict the price of a given ride based on a bunch of features. I'd also like to note we have some weather data available to us, which I'd like to include in our predictions. So let's hop into the notebook. We're just going to do a simple linear regression model, but we're going to go through we're basically going to merge the two data frames together and then use as much feature data as possible to predict. So I'm using NumPy and Pandas just for working with the data, and then the train test split function and standard scalar from sklearn for preprocessing. Then our model will just be linear regression. So let's go ahead and import that, and we have two different CSV files I want to get. So I'll call ridesdf, which will be our data frame, will be pandas.readcsv, and I'm going to get the cabrides.csv file and copy the file path. And then for the weather data frame, it will also be pandas.readcsv, but for the other CSV file. So we'll paste both of these in, and we'll take a look at them. So ridesdf has all our rides, and weatherdf has all our weather. So let's get a little info on each of them. So for ridesdf.info, you can see we have 6 object columns, so we have some encoding to do, and we also have one column here, which is what we're trying to predict, which has null values. So because this is what we're trying to predict, I'm just going to go ahead and drop the targets that have no value there, because there's no point in trying to predict a value that doesn't exist. And for weatherdf, let's take a look at the info for this one. We have missing values in the rain column, which I assume to mean there was no rain that day, so I will just set those missing values to 0. Alright, so let's clean up each one. So first let's clean up the ride data. So cleaning ride data. And basically we're just going to fill in the missing values. We're going to drop the price, the missing prices. So if we look at the isNA matrix for this, it'll tell us if a given value is missing. That will correspond to the NaN here. If we sum over the row axis, we'll get the total number of missings in each column. You can see we have 55,000 examples with no price, so we're going to go ahead and drop those. And because this is the only column that has missing values, we can just say ridesdf equals ridesdf.dropNA, which will drop any rows or columns with missing values depending on the axis we specify. In this case, we're dropping rows, so we drop axis 0, drop from axis 0. And because we're dropping rows, the indices on the side are going to get messed up, so we're going to reset the index afterwards. And I'm including drop equals true here, so that the old indices don't become a new column. And we can, yeah, that should take care of it. Now let's clean up the weather data. Cleaning weather data. So for our weather df, let's also get the total number of missing values in each column. And we only have 5,000 in rain, which again, like I said, I'm going to assume this means no rain. So we can just set those equal to 0. So weatherdf equals weatherdf.fillNA, which will fill any missing values with a given value, and we're just giving it 0 to fill. Alright, so the data has been cleaned up, and now what I'm going to do is create a new data frame, which will have the average weather for a given location. So the reason I'm doing this, if we look at weatherdf, currently this data frame shows the temperature, cloud cover, pressure, rain, humidity, and wind for a given location during a given time. And the timestamps don't exactly match up with all the timestamps in our rides. So what I'd like to do is take this df and group it. So I'm going to do .groupBy, and we're grouping by location. So what this will do is group the data frame into different sections for each location. So it'll send all of the Back Bay location records into one group, send all the Beacon Hill records into another group, send all the Boston University records into a third group, and so on. And then we can get the mean of each group using the .mean function. And so you can see each group has, this is the mean of each group. And so what I'll do is use this as more feature data. Because our rides each have a destination and a source that correspond to one of these values, then we can use all of these as values to be used as features. So what I'll do is call this, actually what we can do is grab this, and if we type .reset index on it, this time drop equals false, that will use the old index, which was our location, as a new column. And so now we have a data frame that has the average weather statistics, or the mean weather for each location over all days, all timestamps. So the timestamps is no longer useful. This is just showing an average timestamp, which is not useful data. So I'm going to call this average weather df, and then I'm going to drop the timestamp column from average weather df. So .drop timestamp from axis 1. All right, and so this is the weather data frame now. It's called average weather data frame. So let's merge the data frames. So currently okay, so if we look at rides df, right, we have a source and a destination. So I want to include the weather for the source and the weather for the destination for each example. And so what I'll do is I'll take average weather df and I'll create two different versions of it. So down here, if we take average weather df and we rename the columns, so let's rename it like so. We can have a dictionary that maps the old column name to a new column name. So let's map location to source, and it's important that this is what we want to merge on. We want to merge the sources to these values here. So these column names have to match up. So that's why I'm calling location as source. And then we're going to, for all the rest, we have temp, we have clouds, we have pressure, we have rain, we have humidity, and we have wind. And I want to map each one of these to a I just want to put a prefix onto the beginning of each of them. So we can just do that by going in here, copying, colon, space, and then in each one of these, I'm just going to write source temp. So if we look at this, we've now renamed the columns so that we just, you'll see why I'm doing this in just a second. Let's call this source weather df. And we can just take a look at that at the bottom here. Okay. I want to do exactly the same thing, but for the destinations now. So it's actually the same data, but we're going to merge it in a different way. So this will be destination weather df, and location will now be changed to destination because we're going to merge on the destination column now. And then all of these sources are just going to become destination. And down here. So currently they're the same data frame, just with different column names. And now what I can do is take our rides df and merge. I'm going to merge the source df with the rides df, and I'm merging on source, which is this column here. So we're going to merge these two data frames on the source column. So basically, it's going to, because we're calling it on rides df, it's going to go for each example. It's going to take the source. It's going to look at the value for that source in our source weather df, and it's going to take all the data associated with that record and put it onto the end of each record. So like this. source weather df actually. You can see we now have all the source weather columns added on to our data frame, and these come from whatever our original source value is. And I'd also like to merge the destination weather. So what I'm going to do is backslash to continue the logical line, and then another backslash, and then continue it, and merge again. This time the same thing, but it's going to be the destination weather df. And of course here we're merging on destination. So this will be called data. This is our main data frame now. Okay, we can take a look at it down here. And you can see we now have both source values and destination values that come from the values stored here and here. Alright, so now we can start pre-processing. So for pre-processing, I'm going to create a function called preprocess inputs. We'll take in a data frame, it'll make a copy of the data frame, and then it will return the data frame. And so right now all it's doing is making a copy, but we're going to pass in our data and store the processed version as x, which currently looks exactly the same as data, but now if we change things in here, we can see the results as we go. So first thing to do is drop the unneeded columns from this dataset. So by unneeded, I mean the ID obviously is not going to be useful because these are all unique identifiers for a given ride. So let's drop that with df.drop ID, and we're dropping from axis 1, which is the column axis. And I can't actually see all the columns right now. Look at this ... So I'm going into the console and typing pandas.set option max columns none. Now we can reload it and take a look. So we no longer have the ID, and you can see that everything from here on is all of our weather data. So we're looking at this stuff. Distance, definitely useful. Cab type, useful. Timestamp, I don't know, I guess we could keep it on there. It is a measure of how recent a ride is compared to the others. So I guess it has probably has some valuable information in it. I won't drop it. The destination is useful, source is useful, price is what we're trying to predict. Surge multiplier, I'm not entirely sure what this means, but I'm going to leave it on because I don't see a reason to take it off. I just want to make sure that these aren't all the same values, so let's just check that. X.surge multiplier dot unique. Yeah, we have multiple values in there, so let's keep it on. Product ID, this is probably useful. Name, probably useful. So we're going to keep all this data. And so we can just do that. I'll just say drop ID column. And then let's binary encode the cab type. So we know it's either Lyft or Uber, so we can double check this by, we can make a dictionary that's going to map a column to the length of unique values in that column. So x sub column dot unique, and then take the length for every column in. I could do x dot columns to get the number of unique values in every single column, but this is also including all of the numerical columns, which have many unique values, and it's not really useful to see. So instead of doing x dot columns, I'm going to do x dot select dtypes object dot columns, and this will just do it for the object columns, for the string columns. Alright, and you can see there are two values in cab type, so it's a binary encoding. So binary encode cab type column. And binary encode is easy. We're just going to take the column and set it to a copy of itself, but with the dot replace function called, and we're going to specify the mapping in here. So let's take a look at what kind of values we have. It should just be Lyft and Uber. So dot unique. Yeah, just Lyft and Uber. So we're going to map Lyft to 0, and we'll map Uber to 1. And this is completely our choice. Then we'll one-hot encode the remaining values. One-hot encode whoops, one hot encode remaining categorical columns. So we're doing one hot encoding here because all of these take on more than two values, and there's no distinctive ordering between the values. So they are candidates for one hot encoding. And so I'm going to create a function that's going to do that for us. One hot encode. It's going to take in a data frame, a column, and a prefix. We'll start by creating a copy of our data frame. Then we'll create some dummies. So we're going to use pandas.getDummies. In this function, very useful function, basically we pass in a column. Let's say we do the name. So I'm passing in name, and so it sends each unique name to its own column, and then each example is represented as a one hot vector, where the 1 represents the original value of that example. So over here we had shared, Lux, Lyft. So over here we have a 1 in shared, a 1 in Lux, and a 1 in Lyft. And now we can also include a prefix here, let's say nm for name. That will just add nm to the beginning of each column so that we know where these columns are originally coming from. So in here I'm going to pass in the df subcolumn with whatever the prefix is. Prefix equals prefix. Then we can concatenate together the original data frame and the new dummies we just created side by side, so axis 1. And then we can drop the original column from which we created the dummies, because it's no longer of use to us. So we're going to return df at the end, and there we go. So let's one hot encode our categorical features. So over here, all we have to do is say for each column and prefix in this list of tuples I'm going to specify. So actually, let's look back at here. Where is it? Where is it? Down here. So these are our one hot columns. We're not doing cab type since we binary encoded that, but I'm going to grab all of these and put this in our list and just delete the dictionary element, dictionary aspect of it. And so here are the columns we're going to one hot encode, and I want to get prefixes for each one, so I'm actually going to include them in tuples, and we're going to pass in the prefix for each one along with it. So I'll use dest as the prefix for destination. We can do src for source. We can do PID for product ID, and we'll do nm for name. Alright, and then for each column prefix pair that we pass in, we're going to call one hot encode, passing in df, the column, and the prefix. And so this will call our function up here, and we should have our one hot encoding done. So let's take a look. Alright, we have all our one hot columns at the end now, and all of our data is now numeric. So we're ready, we're about ready to train. The last few things to do is to split the data and scale it. So first let's split df into x and y. So y is going to be what we're trying to predict, in this case the price. So y equals df sub price, just the price column, and then x is going to be everything except the price column. So we're dropping it from axis 1, storing that in x, and then we're going to do our train test split, which will, so train test split is a function from sklearn, and it will take in our x and our y. We'll specify a train size, 70% works. That will also shuffle the data, and then it will make the split. I want to include a random state to ensure that the shuffle and therefore the split is always done in the same way. And then this will return 4 new sets of the data, which will be xtrain, xtest, ytrain, and ytest. And we can return these 4 sets of the data instead of just x and y, instead of just df, I mean. So let's get those over here, and then we'll take a look at xtrain. So this is just 70% of the data, and it no longer includes the price column. Ytrain, on the other hand, will just be the price column, also for the 70% of the data. The test set contains the other 30%. Alright, so now we just scale the data. So what I mean is each column currently takes on a very different range of values. This one is really high values. These ones are very low. This one actually is just 0 and 1. So let's scale it so they all get the same range. I'm going to use a standard scaler, which is actually, it's just going to give each column a mean of 0 and a variance of 1. So that's from sklearn, and we can fit that scalar just on the train set because we want to assume we don't have access to the test set at the time of preprocessing. Then both xtrain and xtest will become scalar.transform, in this case xtrain, and in this case xtest. So this actually returns a NumPy array, so it's no longer a data frame, but you can see it is scaled. So let's turn it back into a data frame for both of these, pandas.dataframe, and I'm just going to call the columns the same as x.columns, so the column names stay the same. And then we should be ready to train. So here's our new data. You can see now that the mean of each column is extremely close to 0, and the variance of each column is extremely close to 1. So let's start training. I'm going to create just a simple linear regression model, and we're going to fit the model to the train set, xtrain, ytrain. And we'll print out the results. So we're going to call model.score to get the results, and by default, for a regression model, sklearn will return the r-squared score, which is a good way to understand how your regression model is doing. It basically measures how dispersed the data is around your fit. So model r-squared, I'll say actually test r-squared, because it's on the test set, r-squared score, and we'll display this to 5 decimal places and format it with model.score on the test set. And we get an r-squared score of 0.928, so fairly good, especially for such a simple model. I'm sure if we went more in depth and tried to find a model, try to find the best model, and tried to optimize that model, we could probably even get better than this. So that will sum up today's video. Thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.